Hello kids, how are you? I hope you all are doing well. So welcome to today's maths class, and today we'll do rational numbers. We all are familiar with the counting numbers, for example the natural number 1, 2, 3, 4 and so on, denoted by capital N. Let us represent them by drawing circles as shown in the figure 1. Need for rational number. These are natural number or number may be represent on number line. Natural number 0 के बाद right hand side पे 1, 2, 3, 4, 5 and so on. Do you think that this system of number called integer have answers for all the questions that we have in our mind? Yes, you are absolutely right. It is insufficient and it does not have answer for the questions like 2 by 3, minus 7, minus 9 upon 7, etc. So there is a need for further extent in system of numbers. Just as we extended the system of the natural number to the whole number and the system of whole number to integers, the system of integer is extended to from the bigger system of the number called rational number and is denoted by Q. Rational number include fraction as well as their negative number. Number like 1 by 2, minus 1 upon 2, 3 by 5, minus 3 upon 5, etc. are all rational number. The circle has grown even bigger so as to accommodate the rational number. The number like has the new numerals for the finite points. Can you know the difference between a fraction and a rational number? Right. The fraction, the numerator and denominator both are natural number, but in rational number the numerator and denominator both are integer. Clear? Also, denominator is a non-zero integer as 2 upon 0, 3 upon 0, 4 upon 0, 10 upon 0, etc. are not defined. So we can define the rational number as follow. Definition. A rational number is a number which can be written in the form of a upon b, where a and b are integer and b is not equals to 0. Thus 3 by 5, minus 7 upon 8, 3 upon minus 5, minus 19 upon minus 12, etc. are all example of rational number. Tips. All fractions are rational number. All natural number, whole number and integer are rational number. Minus a upon b, a upon minus b equals to minus a upon b. Next, properties of rational number. If numerator and denominator of a rational number is multiplied by the same non-zero integer, the value of rational number does not change. Means if we multiply numerator and denominator both by the same number, so the value will not change. For example, 3 upon 7. So here we multiply the numerator and denominator both by 2. So we will get 6 upon 14. Clear? So the value will not change. Next, if numerator and denominator of a rational number is divided by the same non-zero integer, then the value of rational number does not change. For example, 36 upon 48. So here we have divided both the numerator and denominator by 2. So 18 upon 24. Equivalent rational number है, so value will not change. Let a upon b and c upon d be two rational number. If a into d equals to b into c, then a upon b equals to c upon d. Next, methods of comparing rational numbers. There are two methods to compare the rational number. One is cross multiplication method and other is by making equal denominator like terms. Clear? So first method, cross multiplication method. Let a upon b and c upon d be two rational number. If a into d is greater than b upon c, then we can say a upon b is greater than c upon d. And if a into d is less than b into c, then a upon b is less than c upon d. If a into d equals to b into c, then a upon b equals to c upon d. Second method is by making equal denominators. Take the LCM denominator for all rational number, multiply each rational number with the suitable number which make it equal to the LCM of denominator. The number having greater numerator is greater in value. We'll take an example. Express each of the following into standard form. So first is minus 42 upon 98. Standard form means lowest term में लिखना है. So minus 42 upon 98, HCF of 42 and 98 is 14. So we'll divide both the numerator and denominator by the HCF, that is 14. So we'll get minus 3 by 7. That is the standard form. Clear? Some more examples are given here. You have to practice them. Next is exercise 1A. Express each of the following rational number into standard form. First is minus 35 upon 98. So HCF of 35 and 98 is 7. So 7 से divide करेंगे 5, 14. So minus 5 upon 14 is the standard form. Clear? You have to practice all the questions. Next is representation of rational number on the number line. For that, draw a line and take a point A on it and mark it 0. Take numbers at equal distance, right side 1, 2, 3, 4 all positive number and the left side minus 1, minus 2, minus 3, minus 4 and so on all negative numbers. When we represent a rational number on the number line, then we divide one part of the number line as many times as denominator has the number. We'll take an example. Represent 2 by 5 and minus 3 by 5 on number line. For that, draw a line and take a point O on it. It is marked by 0. First, we will draw this number line and this is 0. Right hand side पे all positive number, left पे all negative number. So if we have to represent 2 by 5, clear, denominator is 5. So 5 equal part होंगे. As you know, 5 by 5 will represent 1. Clear? So 2 by 5 will be between 0 and 1. So 5 equal part करेंगे 1, 2, 3, 4 and 5. First part will represent 1 by 5. Second 2 by 5, 3 by 5, 4 by 5 and this is 5 by 5. So ये हो जाएगा 2 by 5. This way we will represent 2 by 5. If we want to represent minus 3 by 5, negative number है. So left में होगा 0 के. Again, as we know, minus 5 by 5 represent minus 1. So 5 equal part हो जाएंगे 1, 2, 3, 4 and 5. So first part minus 1 by 5, minus 2 by 5 and this is minus 3 by 5. Clear? Next is rational number between two rational number. There are infinitely many rational number between any two rational number. There are many methods to find out rational number between two rational number, but generally we use two methods. First is by making denominator equal, second by converting fraction into decimal. We will take an example. Write any four rational number between minus 3 and minus 1. So we have to write four rational number between minus 3 and minus 1. Minus 3 can be written as minus 30 upon 10. Here we have multiplied both numerator and denominator by 10. And minus 1 can be written as minus 10 upon 10. Here also we have multiplied numerator and denominator with the same number. So denominator same हो गया 10, 10. Now we can write minus 29 upon 10, minus 28 upon 10 because minus 10 और minus 30 लेस है तो हम यहाँ से स्टार्ट करेंगे इंक्रीजिंग ऑर्डर में -29/10, -28/10, -27/10, -26/10 एंड सो ऑन टिल -10 तक हम लिख सकते हैं. क्लियर? सो यू कैन राइट एनी ऑफ द 4 रैशनल नंबर बिटवीन -3 एंड -1. क्लियर? नेक्स्ट इज एक्सरसाइज 1B. Represent the following rational number on the number line. First is 2/3. So first we'll make a number line. This is 0. 2/3 positive number है. 1, 2 and 3. As we know 3/3 will represent 1. So denominator 3 है तो 3 equal division हो जाएंगे. 1 and 2 and 3. So this is 1/3 and this one 2/3 और ये हो जाएगा 3/3. So this is 2/3. So this way we can represent the rational number on number line. So you have to practice all these examples. We'll move to next topic, that is properties of addition on rational numbers. Properties of addition on rational number are similar to the properties of addition of integer. First, closure property. The sum of any two rational number is always a rational number. If a upon b and c upon d are two rational number, then a upon b plus c upon d is also a rational number. For example, -5/16 plus 7/12 करेंगे, we'll get 13/48. That is a rational number. So sum of two rational number is always a rational number. Next, commutative property. Two rational number can be added in any order. Their sum remains same. If a upon b and c upon d are two rational number, then a upon b plus c upon d equals to c upon d plus a upon b. For example, -2/3 plus 1/6 करेंगे, we'll get -1/2. Now change the order. 1/6 plus -2/3, again we will get -1/2. So if we change the order, the sum will remain same. Next is associative property. The sum of 3 or more rational number does not depend on the order in which they are grouped. Order is immaterial. Thus, if a upon b, c upon d and e upon f be any three rational number, then a upon b plus c upon d plus e upon f equals to a upon b plus c upon d plus e upon f. For example, consider three rational number 3/4 -2/5 and -7/10. So first we have done, हमने क्या किया, 3/4 plus -2/5 इन दोनों की ग्रुपिंग की है. First we will add these two rational number, then we will add -7/10. So we will get -7/20. Now we change the grouping. Now हमने -2/5 and -7/10 की ग्रुपिंग कर दी है. First we will add these two rational number, then जो भी आएगा sum उसमें 3/4 ऐड करेंगे. In this case we get the sum -7/20. In both the cases, the sum will remain same. So if we change the grouping, the sum will remain same. That is associative property. Clear? Next is existence of additive identity of property of 0. Sum of any rational number and 0 is the rational number itself. किसी भी rational number में 0 ऐड करेंगे, we'll get that rational number only. Thus, if a upon b is any rational number, then a upon b plus 0 equals to a upon b plus 0 equals to 0 plus a upon b. Means किसी भी rational में 0 ऐड करेंगे तो हमें वही rational number मिलेगा. The rational number 0 is called the identity element for addition of rational number. For example, let us consider the rational number -3/8. So -3/8 plus 0 will give you -3/8. Same rational number. Clear? Next, existence of additive inverse or negative of the rational number. For every rational number a upon b, there exists a rational number minus a upon b, such that a upon b plus minus a upon b equals to 0. Minus a upon b plus a upon b minus a upon b is called the additive inverse of a upon b, and a upon b is called the additive inverse of minus a upon b. For example, 3/5 और उसका additive inverse को add करेंगे minus 3/5 will get 0. Clear? Thus 3/5 and minus 3/5 are additive inverse of each other. Next, property of 0. If 0 is added to any rational number a upon b, the sum is the same rational number a upon b. For example, a upon b plus 0 equals to 0 plus a upon b equals to a upon b. और 2/3 में 0 add करेंगे will get 2/3. Next, addition of rational number. Type 1. When the denominator of given rational number are same. अगर डिनोमिनेटर सेम है तो क्या करेंगे, लेट ए अपॉन बी एंड सी अपॉन बी आर टू रैशनल नंबर, देन ए अपॉन बी प्लस सी अपॉन बी इक्वल्स टू हो जाएगा ए प्लस सी अपॉन बी. मीन्स इफ डिनोमिनेटर आर सेम, व्हाट विल वी डू, वी विल सिंपली एड द न्यूमरेटर एंड राइट द कॉमन डिनोमिनेटर बिलो. नेक्स्ट, टाइप 2. When the denominator are given rational number are different. In this type of question, take LCM of denominator and express each of the given number with this LCM as the common denominator and then add. Now we'll take an example. Find the sum 5/23 plus 3/23. In this case, both the denominator are same. So what will we do? We'll simply add the numerator 5 plus 3 upon 23, that is 8 upon 23. Clear? Next is subtraction of rational numbers. Type 1. When the denominator of given rational number are same, then let a upon b and c upon b are two rational number. Where denominator same, then a upon b minus c upon b equals to हो जाएगा a minus c upon b. Means हम simply जो न्यूमरेटर है उनको सब्ट्रैक्ट कर देंगे बिगर में से लेस वाला, एंड जो कॉमन डिनोमिनेटर विल राइट बिलो. टाइप 2. When the denominator of given rational number are different. In this type of question, take the LCM of denominator and express each of the given number with the LCM as the common denominator and simply subtract. Now we will take an example. Subtract 5 upon 11 from 6 upon 11. 6 upon 11 में से subtract करना है 5 upon 11. So denominator same है तो हम करेंगे 6 minus 5 upon 11, that is 1 upon 11. Clear? Some more examples are given here. Do practice them. Next is exercise 1C. Fill in the blanks and write the name of use property also. So first question is minus 3 upon 4 plus 6 upon 7 equals to 6 upon 7 plus आ जाएगा minus 3 upon 4. So this property is commutative property. We change the order, the sum will remain same. This is commutative property. So you have to practice all the questions. We will move to next topic. Next topic is properties of multiplication on rational number. First, property 1. Closure property. According to this property, the product of two rational number is always a rational number. Let a upon b and c upon d are two rational number, then their product a upon b into c upon d equals to a into c upon b into d is also a rational number. For example, consider two rational number 3 upon 4 and minus 5 upon 7. So their product 3 upon 4 multiplied by minus 5 upon 7, that is minus 15 upon 28, that is also a rational number. So product of two rational number is always a rational number. Next, property 2. Commutative law. Product of two rational number remains same whenever their order of rational number अगर चेंज भी कर दे तो जो प्रोडक्ट होगा वो सेम रहेगा. Let a upon b and c upon d are two rational number, then a upon b multiplied by c upon d equals to c upon d multiplied by a upon b. एग्जाम्पल लेते हैं. कंसीडर टू रैशनल नंबर माइनस 5 अपॉन 9 एंड 3 अपॉन 11. minus 5 upon 9 into 3 upon 11, that is minus 15 upon 99. Now if we change the order, 3 upon 11 multiplied by minus 5 by 9, again the product is same, minus 15 upon 99. Hence commutative law is verified. Next, property 3, that is associative law. Product of three or more rational number remains same whatever the grouping of the rational number. Let a upon b, c upon d and e upon f are three rational number. Then a upon b multiplied by c upon d multiplied by e upon f equals to हो जाएगा a upon b multiplied by c upon d multiplied by e upon f. Example लेते हैं. Consider the rational number minus 3 upon 7, 1 by 5 and 2 upon 11. Now फर्स्ट हमने ग्रुपिंग की इनकी, इनको मल्टीप्लाई किया एंड इनके प्रोडक्ट को 2 by 11 से मल्टीप्लाई किया, विल गेट माइनस 6 अपॉन 385. नाउ वी चेंज द ग्रुपिंग, इन दोनों की ग्रुपिंग की एंड देन उसको माइनस 3 by 7 से मल्टीप्लाई किया. अगेन वी गेट द प्रोडक्ट माइनस 6 अपॉन 385. इन बोथ द केसेस द प्रोडक्ट इज सेम. सो ग्रुपिंग चेंज करने से उसका प्रोडक्ट जो होगा वो चेंज नहीं होगा, इट विल रिमेन सेम. नेक्स्ट, प्रॉपर्टी 4, multiplicative inverse. Every non-zero rational number a upon b has a multiplicative inverse, that is b upon a. Since a upon b multiplied by b upon a equals to 1, so b upon a is called the multiplicative inverse of a upon b, and a upon b is called the multiplicative inverse of b upon a. b upon a is also called the reciprocal of a upon b. Tips: multiplicative inverse of the 0 does not exist. Remember, 0 has no reciprocal since 1 upon 0 is not defined. Now take an example. Multiplicative inverse of minus 5 upon 9 is minus 9 upon 5. Next, property 5, multiplicative identity. Product of a rational number and 1 is a rational number itself. Let a upon b is a rational number. If we multiply it by 1, we will get a upon b, the same rational number. So 1 is called the multiplicative identity for the rational number. Example, consider a rational number minus 5 upon 13. If we multiply it by 1, we will get minus 5 upon 13, same rational number. So किसी भी रैशनल नंबर को 1 से मल्टीप्लाई करेंगे, विल गेट द सेम रैशनल नंबर. क्लियर? नेक्स्ट, प्रॉपर्टी 6, multiplicative property of 0. Product of a rational number and 0 is always 0. Let a upon b a rational number, then a upon b multiplied by 0 equals to 0 multiplied by a upon b, that is to 0. For example, 17 upon 25. If we multiply it by 0, we will get 0. Clear? Next is property 7. Distributive law of multiplication over addition. Let a upon b, c upon d and e upon f are three rational numbers. Then a upon b multiplied by c upon d plus e upon f, that is equals to a upon b multiplied by c upon d plus a upon b multiplied by e upon f. a upon b को पहले हमने c upon d से मल्टीप्लाई किया, देन प्लस का साइन है, देन a upon b multiplied by e upon f. Clear? Now we will take an example. Consider the rational number minus 3 upon 5, 1 upon 10 and 4 upon 15. So minus 3 by 5 को हमने 1 by 10 से मल्टीप्लाई किया है, प्लस 4/15 है. सो फर्स्ट हमने क्या किया है, फर्स्ट केस में हमने इसको सॉल्व किया है एलसीएम लेके एंड देन -3/5 से मल्टीप्लाई किया. सो विल गेट -11/50. नाउ वी हैव यूज्ड द डिस्ट्रीब्यूटिव प्रॉपर्टी. सो हियर व्हाट वी हैव डन, -3/5 को पहले 1/10 से मल्टीप्लाई किया है, देन प्लस का साइन है, देन -3/5 को 4/15 से मल्टीप्लाई किया है. अगेन विल गेट द सेम आंसर -11/50. So it is clear that -3/5 into 1/10 plus 4/15 equals to -3/5 multiplied by 1/10 plus -3/5 into 4/15. Hence, distributive law of multiplication over addition is verified. Clear? Now we'll take an example. Find the multiplicative inverse reciprocal of each of the following rational number. First is -3/14. So multiplicative inverse और reciprocal क्या हो जाएगा, denominator ऊपर चला जाएगा and numerator will come down. So -14/3. Clear? Next is multiplication of rational numbers. Let a upon b and c upon d be any two rational number. Then a upon b multiplied by c upon d equals to a into c upon b into d and simply it. Means numerator का numerator से multiply होगा, denominator multiply by denominator. Now we'll take an example. Find the product of 3/4 and -8/15. 3/4 multiplied by -8/15. Numerator multiply by numerator. So माइनस जो कॉमन है उसको अपने बाहर ले लिया, 3 into 8/4 into 15. क्लियर? तो ये आ जाएगा 24/60. So आंसर आ जाएगा -2/5. दैट इज इन सिंपलेस्ट फॉर्म. क्लियर? नेक्स्ट एक्सरसाइज 1D. Fill in the blanks and name the use property also. -6/17 into 8/19. So ये हो जाएगा 8/19 multiplied by -6/17. This is the commutative property of multiplication. Clear? So do all the questions of this exercise. Do practice all the questions. We will move to next topic. Our next topic is properties of division on rational number. First property, that is closure property. According to this property, let a upon b and c upon d be two rational number such that a upon d is not equals to 0. Then a upon b divided by c upon d is also a rational number. For example, consider two rational number -5/11 and 10/33. So -5/11 divided by 10/33, मल्टीप्लाई का साइन आ जाएगा, रेसिप्रोकेट हो जाएगा, 33 ऊपर आ जाएगा, 10 आ जाएगा. सो आ जाएगा -3/2 विच इज़ अ रैशनल नंबर. क्लियर? अगर जो डिनोमिनेटर है दैट इज नॉट इक्वल्स टू 0, देन ओनली वी कैन अप्लाई दिस प्रॉपर्टी. नेक्स्ट प्रॉपर्टी 2. For any rational number a upon b, we have a upon b divided by 1 gives you a upon b. For example, -3/8 divided by 1, that is equals to हो जाएगा -3/8. Next property 3. For every non-zero rational number a upon b, we have a upon b divided by a upon b, that is equals to 1. Means if we divide any rational number by the same rational number, we will get 1. For example, 10/17 divided by 10/17. So we'll get 10/17 into 17/10, that is equals to 1. Next, subtraction is nor commutative neither associative for the rational number, but closed under subtraction. Similarly, division is nor commutative neither associative for rational number, but it is closed under the division except 0. Example लेते हैं, divide 11 upon 23 by 33 upon 46. So 11 upon 23 divided by 33 upon 46. डिवाइड का साइन हट जाएगा, मल्टीप्लाई का साइन आएगा, एंड साइन के बाद जो है वो क्या हो जाएगा, रेसिप्रोकल हो जाएगा. मीन्स 46 ऊपर आ जाएगा, 33 नीचे हो जाएगा. And so 2 by 3 is our answer. Clear? Next is exercise 3E. Divide -5 upon 18 by 10 upon 27. -5 upon 18 डिवाइड है, मल्टीप्लाई हो जाएगा और नेक्स्ट का जो है रेसिप्रोकल हो जाएगा. -1 2 9 2 is 18 and this is 3. So ये हो जाएगा -3 upon 4. So that is our answer. You have to practice all the questions. We will move to next topic. Next is word problems. Example 1. Weight of the sugar in a bag is 95 1 upon 5 kg and the weight of empty bag is 2 1 by 4 kg. Find the weight of the filled bag of sugar. So total weight find करना है. Weight of the sugar in bag, that is 95 1 by 5, that is 476 upon 5 kg, and weight of empty bag, that is 9 upon 4 kg. So total weight of filled bag with sugar हो जाएगा, दोनों को ऐड कर देंगे. So LCM लेंगे, 20 आ जाएगा. So ये हो जाएगा 1949 upon 20, that is an improper fraction. So we'll change into mixed fraction, that is 97 9 upon 20 kg. That is the total weight. Next is exercise 1F. A bag of rice contains 48 1 by 4 kg and weight of empty bag is 1 by 5 kg. Find the weight of filled bag of rice. So we have to add. So we'll add both. होल पार्ट को हम अलग से ऐड कर देंगे एंड फ्रैक्शन को 1 by 4 plus 1 by 5. So that is 49 एंड यहाँ पे एलसीएम लेंगे 20. 4 5 ये हो जाएगा 5 plus 4, that is 49 9 upon 20 kg. That is the total weight. Clear? So you have to do all the questions. Here we end the chapter. I hope you understand the chapter well. Now you have to practice it.